My name is Celia Cano here with Marine Technology TV, and I'm here today with Jim Bellingham, Executive Director at the Institute for Assured Autonomy at Johns Hopkins University. So, jumping right into it, I know that you are well known to the MTR audience. This is not your first time speaking with us, but can you give a brief career overview?
I started out in physics, so my PhD's in physics. I happened to have a couple of really fortuitous interactions with people who had maritime interests of various types. And so shortly after I graduated, I went back to MIT and started something called the Autonomous Underwater Vehicle Laboratory there, which was in the Sea Grant College program. I ran that for 10 years. It was a really fabulous time in my life. Sort of towards the end of that, we started Bluefin Robotics, and together with my good friend Frank Van Mierlo and a bunch of folks from the laboratory, including pretty much everyone from the lab, students, everyone went. And then out to the West Coast to the Monterey Bay Aquarium Research Institute, where I worked for Marcia McNutt out there for 15 years, and had a terrific time there. So I grew a lot, I think professionally. Brought that back to Woods Hole with me for a few years in Woods Hole, and in the middle of COVID, I got this call from Johns Hopkins, and have been here ever since. So.
Awesome. And you said that, you kind of bounced all over. So at what point did you really figure out that your career would be one in the maritime or subsea sector?
Yeah, I have to say that there were a lot of clues if I had been paying attention along the way. So I definitely gravitated towards maritime activities. So I took a sonar class, absolutely no connection with anything I was doing in graduate school. Took some geophysics, some marine geophysics classes. But those things didn't really coalesce for me until after I graduated. I'd spent, almost 6 years, if you count undergraduate, in laboratories, which were fabrication laboratories. So labs with no windows, where you suit up. And boy, I was really looking for a change. And, Sea Grant was trying to get this underwater vehicle program going. They had funded me for the graduate work, and so I had always heard Chris talking about this and had been rather jealous of these folks getting to work on the marine robotics side of things. And they finally sort of broke down and decided they would sort of pool their money and hire someone to really get the program up and running. I saw a note in the Infinite Corridor at MIT. I called them up. I walked in cutoff shorts and a T-shirt, and I walked out with a job, much to my wife's dismay. So there I was back at MIT. They were great times.
That's a fantastic story. And I totally remember, in college taking classes that I didn't think had anything to do with what I wanted to do. And then, several years later out of undergrad, they've proven way more important than things that I did have to take for my major. So I totally, I get that experience.
Yeah, I think it's now that I'm a professor, kind of later in life, I keep that in mind, right? There are things that you teach your students, that you expose your students, that kind of go in the back of their heads, and you never know when they're going to blossom.
Exactly. So, looking kind of at your career in terms of all the different expeditions you've been a part of, what do you consider to be your most notable or your most gratifying expedition to date?
Um, I guess there's two answers to that. I think the first cruise I went on for me was really, in a personal sense, life-changing, because I suddenly discovered there was this whole thing of going to sea. It was in the Antarctic. Lots of things broke. Lots of things had to be fixed. And it was for me, as I said, just a life-changing experience. I can remember at one point we're coming out of the ice, everything's broken. The fog, you're moving into the fog as you're reaching the ice edge, and I just thought, I have to come back here again. So that was definitely one on the personal level. On the professional level, for me and many of my colleagues, things really came together in a field program which we called the AOSN 2003 field program. It was out of Monterey Bay. And at that point, we had all been working on these various types of robotic concepts. So gliders had been in development. There'd been the web gliders, there were the spray gliders. John Erickson was developing his sea gliders. Those were all part of that program. And we had a set of docking activities going on, and it all came together. We've been running field programs where we tested the technological components, but it didn't really all work together until that 2003 experiment. And it was just amazing, right? Here we were onshore running this fleet of underwater vehicles, and they're sending data back to shore. They're going into the oceanographic models. We're getting predictions in real time. We're having these giant meetings discussing what it all means and where to send the vehicles next. And I just remember going, and all of this is occurring out there at Mbari in a building we used to call Building G. I don't think it exists anymore. There used to be a place, Phil's Fish Market, on the first floor, which had great food. And we were doing all of our work on the second floor. And so you can imagine we'd go down for lunch down to Phil's. And I remember with one of my colleagues who was saying, we can get a beer and sit back and talk about anything we want, and we're still doing oceanography. It was like the robots are out there, they're working. It was just, we'd been working on it so long and so hard. It just was kind of amazing when it all finally came together. So that 2003 field program for me, I always remember that as a particularly special one, for those reasons.
Yeah, it sounds like kind of a shift, almost like a notable marker kind of in your career where things, kind of became real almost.
It was astonishing, right? I remember that I realized, if we put one more robot in the ocean, we're going to break our data system. So it really began to shift my idea of where the problems were. I suddenly became very interested in data systems, and data integrity and QC and communications and a whole set of things, which honestly, as a vehicle developer, I hadn't really worried about before. But yeah, it definitely changed how we thought, and the whole collaboration part of it. I love working in teams. For many of these folks, it was people like Alan Robinson and Russ Davis, and truly the giants of oceanography, who, both of which, unfortunately, have passed away. And so an opportunity to kind of work shoulder to shoulder with individuals like that is something that, I'll always cherish. It was a very, very profoundly satisfying time, as your question started with. Yeah.
Yeah, that sounds incredible. So kind of on the flip, or maybe similar, but what do you consider to be your greatest failure? And then how did that failure help to strengthen your career?
Oh gosh. Well, so as you get older, you develop a longer and longer list of failures, and you love talking about them because they all make great stories. Right? There I was hanging on to the robot with one hand and the rib with the other, and the shark coming at me, right? So no, I think the two failures for me that really changed how I look at things revolved around steps. So first of all, we had the cruise we called in our lab the cruise from hell, where we were working with PMEL, and we were working on this event response idea. So ultimately, we wanted to be able to put our little AUV on a fishing boat and then get it out to the Juan de Fuca Ridge, if an eruption was detected in fairly short time. And so we were going out and testing those things on the Disco, which was the Discoverer, which was one of the NOAA vessels of that day. And it was our first time going deep, and we were just completely unready for it. I had a laboratory full of PhD physicists and engineers who were all smart people, but, really didn't have sea experience. And so we all came back from that with a real commitment to, number one, we're going to recruit some people to the team who know this stuff. And number two, we're going to learn it ourselves. But it was a very rough cruise. I can remember one thing in particular was we kept killing hard drives on our main vehicle computers. So we would evacuate the pressure vessel where all of our electronics were contained, and we would evacuate it, an extra couple psi. Because we wanted to be super, we were trying to be super careful. Well, basically, the little magnetic readers in there fly on air, and if you pump all the air out of the volume, they actually don't fly above the disk anymore. They crash into it. And so we went through all of our disks on board and killed them all, and then realized that it was the same disk drive that was in my Mac computer. So we pulled it out of the Mac computer. We were able to reformat the drive. We had one of the graduate students on shore who managed to get into the lab on a Sunday and get us the key files. And it was just a crazy thing, right? Getting all of this stuff together, for things that for I think many other people in the field, this is all kind of obvious, but to us, connector discipline didn't have any, right? Boy, was that ever did that ever come back to bite us? So a lot of lessons there, which then led to a whole set of, boy, we're not going to see again until we've demonstrated to ourselves that we fixed these things. So we spent a lot of time out on, I think it was the Weatherbird out off of Bermuda, convincing ourselves that we knew how things work. I'm not going to say that we were in control of it all by the next time out, but we were a heck of a lot better off. So that was one. I would say the other big failure really revolved around the attempts to transition vehicles from our laboratory, which at some point we got pretty good at running them, and we could take them to sea and we could make them work. But it's a very different thing from handing vehicles off to other people and having them be successful with your technology. And in fact, when you're actually building the vehicles and designing the vehicles, there's a whole different mindset, right? You're not just designing the hardware, you're actually also designing the production methodology. And when you're handing it off to someone else, that whole service, set of processes that you're putting in place isn't just to help the customer, right? It's also to bring all that information as to what's failing back into the company so that you can fix not just the design, but also the manufacturing process. And all of these things, the maturity of the processes that were required to really support systems that were going to be reliable in the field was something that, in my early lab days, we were all researchers kind of turned design engineers. So these were things where, once again, we realized there was an expertise there that we needed that we didn't necessarily have, and we had to go out and recruit it. So those are things that for us, I'm almost embarrassed to say them. Maybe we should blank out this part of the show, but but they were important lessons, and I think most startups, kind of go through some version of this, right?
I was going to say the failures are inevitable, and as long as we're learning from them, that's kind of the best we can ask for. So you with Claudia Gelb have released or about to release a new book called "How Are Marine Robots Shaping Our Future?"
Mm-hmm.
What can our readers and our viewers expect when they pick up the book?
Yeah, so I think that the readers. First of all, the book is really intended for a lay audience. Kind of the idea was to tell the story of what our community does and why it's important to the rest of the world. I think that many of us got into this field because we're excited about the opportunities for discovery. At our heart, humans are fundamentally about exploration, right? It's kind of our history going back to our earliest ancestors. At the same time, we're also tool builders, and to some degree, this is also a story of tools. The ocean is a very hostile environment, and many parts of it are really only accessible through the use of some very complex and cutting edge technologies. And I think that the final element of this really revolves around the fact that the ocean touches really every person, right? We have one chapter which is the ocean in your kitchen, and of course the fish that you eat come from the ocean. Perhaps the power that comes out of your outlet may come from a wind farm. The plastic products may come from petroleum, in effect, from oil wells at sea. When you pick up the telephone and you talk to your relative, In Europe, if you're in the continental US, that communication occurs via the seafloor. So the ocean is a growing part of every person's lives, and in many ways that we're still attempting to understand. And so I think the final message here is there's an interrelationship, this growing interrelationship of humans in the ocean that's occurring that is important for us to understand because the ocean is, after all, most of the planet, and it is where most of the resources are. And at the same time, it also governs our climate system. So it's the largest part of our climate system and the least well understood. And for that reason, we also have to be very careful about it. Because it is all interconnected, and you can't pretend to sort of only do things in one part of the ocean and it's not going to affect others. So there's an issue of stewardship that we haven't fully grappled with in the ocean that we need to develop a clear picture of what those interrelationships are and what our responsibilities are in that overall process. So those are the things, and of course I sprinkle sea stories in there because a lot of times that's how you illustrate these things, right? Is perhaps with personal stories, but also with historical stories. So there's a lot of this history, as I alluded to, interacting with these giants of oceanography. It's a young field, right? And the giants are still around, and that's part of what attracts me to this. You get to work with the folks who literally started many of these things from scratch, and so we're still in those early days figuring out how things work. I think it's a tremendous time to be a young person and to think about going into this because, number one, these are really important problems, so they're meaningful to work on. And number two, there is real opportunities that didn't exist, 10, 20 years ago, and that the tools that we're developing now are really going to open the ocean in many respects to a much more profound understanding. So.
Awesome. The book sounds fascinating. I'm excited to read it. Um, and one question I had, I mean, the second I, saw the title of the book, my first thought was, marine robots and the future of autonomous solutions is a huge topic. So
Mm.
how have you formatted the book to address the complexities of this topic and also the uncertainty of what the future looks like?
Yeah, so yes, this is true. As I teach, that's one of the things I realize is like, well, this will be a simple lecture, and I realize, oh no, wait a minute. In order to explain that, I have to explain these other three things first. And so you're right. It is on the technology side, it's highly interdisciplinary. On the science side, we say ocean science like that's one science, but it's not, right? It's physical oceanography, it's geology, it's geophysics, it's microbial oceanography, it's molecular biology, and of course, intertwined through all of this is a common set of technologies that allow us access to the ocean. So I think we don't attempt to tell the whole story. I think what we attempt to do is to tell enough of the story to get people excited about it and to tell a bit of the history as well. Where did this come from? Those things are not always obvious to folks, right? Oceanography in many respects has very strong roots in what happened in World War II and in the early days of the Cold War. And in fact, in the early, there's an interesting point that oceanography was primarily funded by the Navy until about the mid 90s when NSF surpassed ONR in funding. So there's all of these other interconnections that you kind of need to understand. And then, of course, there's the whole growing activity in industry in the ocean, right, which is moving these large pieces of infrastructure to the ocean. Offshore platforms larger than the Empire State Building sitting on the seafloor, large networks of hardware spanning the size of small cities. And of course, wind farms beginning to occupy more and more of coastal waters, aquaculture. Currently, mostly in fjords and in sheltered areas, but eventually perhaps moving out to deeper water and offshore water. All of these things are going on now, and those are all stories where you want to give them enough to give people a sense of what's going on, why it's going on now, why they should care about it, and hopefully a desire to read someone else's book. So maybe you can take a piece of this and carry it a little bit further.
Absolutely, yeah. And all that makes sense. I think, when I was first thinking about the book, it was just it feels like such an overwhelming topic to tackle, but it sounds like you've got it laid out wonderfully. And again, I'm excited to read it.
Well,
Um,
thanks.
a little bit of a, I guess, a spoiler alert, if you're allowed to spoil a little bit for us. Can you give us a brief peek into the book? How exactly are marine robots shaping our future? Like, what is the answer to that question?
Well, I think marine robots are doing is they're making the ocean accessible in a way that hasn't been accessible before. I mean, we're always going to have ships. We're always going to venture out from Halifax, from San Francisco, from our various ports around the world to the oceans to the various ocean bodies of the world. But robots are increasingly out there all the time. And they're carrying more and more sophisticated instrumentation and beginning to do work at sea. So we're beginning to see systems which have the promise of doing, for example, intervention activities on, for example, offshore infrastructure. So I think that the story of how robots are changing our future is, number one, by making the ocean much more accessible and therefore the resources in the ocean much more accessible. And a lot of this is really being driven by science. So a lot of the innovative work in the creation of these systems starts out by people who really desire to understand how the ocean works as part of our climate system, as a habitat, and to study the seafloor and the geology, which underlies, in most cases, many kilometers of ocean water. And so I think that the story there really is a bit of a race, right? Because on the one hand, we're able to exploit the ocean more profoundly than we were before. But by the same token, when you do that, you really want to understand what the impacts are, and you want to manage that wisely, which I think we certainly, for the most part, attempt to do. But it really does depend on having the right tools to do that. And so each of those is moving forward at a tremendous rate. And I think right now, for those of us who are interested in the science piece of this, making sure that we really do develop that scientific understanding of what's going on, so we can actually make predictive statements, right, about, if we do this, then this might happen with higher probability. We're never going to have certainty in a system that complex, but we need to be able to start applying some level of predictive skill, if you will, to these really tough problems that we have to make decisions about.
Fantastic. And looking a little bit now at both your experience and the book together. So, you're long tenured in the sector. So, what did you learn about the market, about yourself, both those things, and going through the process of writing the book?
Well, okay. So one of the things is that this was I do love the historical aspect of this. It is really fun talking to folks or finding oral histories from folks who are involved in sort of the very early days, and a lot of times there's some very surprising stories. Um, the other piece of this is that I really enjoy working with teams, and working with Claudia was really what made this happen, right? So, I've been kind of imagining a book like this for many years. I used to give these talks, about the blue economy and, the humans' changing relationship with the ocean. But it wasn't until I came to Johns Hopkins and I connected with the Wavelengths folks, and they introduced me to Claudia, that this all really came together. And so, I do think that, like everything in life, there's value in having these discussions with different perspectives about or different windows into the ocean, right? That you get a chance to talk about, and the book was a really great opportunity to have those conversations. we were mostly working remotely because, of course, a lot of this started during COVID. But at some point, we'll get together and have a beer and talk about it, or maybe a cup of coffee.
Amazing. So one last kind of large question, and then we'll start to wrap things up. So there are obviously many applications for marine robotics. So when you look at the tech and you look at the market, where do you see the top one, two, or three opportunities today to fully leverage the capabilities that we have?
Um, so I think that particularly, your readers are probably very aware of the rapid expansion of small companies and activities in small companies developing particularly autonomous surface platforms, but also undersea vehicles, and a lot of times the instruments that go on them. And so, we're at a bit of an inflection point where these vehicles are which are being developed, initially to work independently. So when we put a vehicle in the water, we kind of thought of it as out there operating on its own, and we might coordinate it with other vehicles. But these days, we are thinking more and more about how these vehicles work together. How the surface vehicles might provide, certain, for example, communication or navigation support for undersea vehicles, how the undersea vehicles might, for example, repower themselves from environmental energy in some way, perhaps from those very same surface platforms. And then, as AI accelerates and as our ability to make more sophisticated systems, for example, with manipulators on them, improves, the opportunity to build systems that aren't just surveying the seafloor and developing admittedly spectacular maps of and visuals of the undersea environment, but begin to actually build systems which can autonomously do work in the undersea environment. That'll be another threshold we pass. And that will be, again, sort of begin to change the economics of allowing us to have a more permanent presence in the ocean which will be so critical, I think, for many things. I mean, I think it's kind of obvious why it's valuable to industry, but for scientists, right, so much of what happens in the ocean is episodic, right? And if you go out to sea on a ship, every once in a while you get lucky, and that process occurs while you were there. A friend of mine shared a videotape of him in Alvin as they were out on the East Pacific Rise during a volcanic eruption, and in Alvin down on the seafloor. And of course, in Alvin, you can't see very far. So, kind of the somewhat amusing part of the story is they actually didn't know what was going on for a large part of the dive. It's like, wow, all the tube worms are barbecued and there's stuff raining on us. And they didn't realize they were right next to an eruption. Well, they got very lucky, right? Maybe doubly so. Partly they got lucky they were out there in the eruption, and also they got lucky that they weren't in the eruption. But those moments of chance when you get to see the real transformative activities or processes in the ocean occurring, those are so much more likely if you're out there all the time, right? And you have large sensor arrays and you can detect them when they're happening. So I think those are the things that we're getting closer to. And it's so important in some parts of the world, like the Arctic, where it effectively closes down to us a good part of the year because the ice cover moves in and, our icebreakers move out, and the ocean is largely unobserved. So those are things where I think, we begin to be able to see some tremendous new steps of capability coming as we develop these newer, more capable classes of robotic systems.
Fantastic. Well, it's a very exciting future. I know I'm excited to see what happens. And yeah, so just to wrap up, speaking of the future, do you have any other exciting projects or expeditions that we can keep an eye out for?
Well, I will tell you that I'm very interested in returning to the Arctic. I would very much like to build networked vehicle systems that we could leave behind up there and that we could control remotely. In part because there's a set of colleagues who are working on, for example, shelf processes where the geology, the changing climate, and microbial processes all kind of come together in a way which connect in with a big question mark, if you will, in the climate system. It'd be good to remove that question mark and find out, are we in fact introducing a lot of methane to the atmosphere or not? As we see these large changes in the shelf up there. And so there's a set of technological problems that we have to solve to get there. A lot of them have to do with how you make these autonomous systems reliable on their own when you can't talk to them for a long period of time. And we have some ideas about how to do that we're working on now. Yeah, I'm pretty excited about it. So in my lab, we're kind of gradually building up, the research programs that are targeted at putting the pieces in place to hopefully that kind of return to the Arctic Ocean.
That sounds incredible. Good luck.
Thank you.
Awesome. Well, thank you, Jim, for taking the time today. It's been fantastic to talk about all this with you, and good luck with the potential future expedition. And I'm excited to read the book when it comes out.
Great. Well, we'll make sure you get a copy. Take care.
Thank you.
Bye.